to our work. We want to optimize our work. We go on to add our global least squares objective, which we'll be using for optimization. Our data source, we want it to be from the results table. We want our results should be load cycle table. Our time column should be TS. And our model expression for this should be cell. We want to uncheck this. We go to our voltage losses. We want to set our diffusion, our temperature to T. We want to set our ohmic over potential eta. We want to set our exchange current density. We want to set our diffusion as well. Go on to add another steady. Which will be a time-dependent steady. That will be our parameter estimation. We want to uncheck our default plot. We want to add optimization. Set using this optimization. I want it from least square objectives. Come to control variables and parameters, where we want to add about 3 ohmic inverse diffusion. So we set our scale 0, 1. So we set them as such. We go on to our definitions to add a global variable proof to our work. Our expression will be eta which will go on to duplicate this. it will be this. We go on to duplicate it again the third time. Change this to go to our parameter estimation and want to compute. If you find an error, so there was an error because Comsol detected that this variable is undefined. So we actually go to where this variable is located over here. Then we make sure we input it for this is supposed to be, it's a small l and b dot e caps E, let's go CL. So kindly note that this is an L, small l. So can go ahead to compute, which will solve our work for us. It takes some time depending on your computer processor. Okay, so good. That's been able to compute our work. We move to our cell voltage section, where we select our data set to be parameter estimation 2. We'll plot as well. So there is some changes in our work. Then we move to voltage losses. Also, we set our data set to steady 2 parameter estimation. In there too, you can see some changes. Go to optimization. We go down to output, power solving. We check the plots section. Then we go ahead to compute. Okay. We patiently wait for it to finish computing. Okay, so we go to our tables and we add a table which we'll name as our full load cycle. We want to import our data from here. We go to full data, look for full data. Okay, so there's our full data. So this is what we select for our work. Go on to global definitions. Add another interpolation, which we'll name as ENIST full. So our data source will be from result table. Table will be full load cycle. We'll go ahead to name our functions, what our functions will be. E cell, exponent, full. Let's go full. It's 2. Units is S in here. Go on to our variables. We want to duplicate where we change one section to full. No, not that. Change this part. We add full. This section to as well. We change. We add full. This section. We go on to add another steady. This will be a time dependent steady, which we'll call full load cycle. Predictions. We want to change the time. 1 to 600. want to use user controlled native tolerance. We want to increase, reduce it. We want to modify the model. Disable first variable. We disable optimized. We also change the variables settings to user controlled, where we change the steady to parameter estimation time dependent. We don't want to generate default plots. Move to variables too. Steady one, time dependent two as well. We want to also disable both variables too and optimization. We want to disable them. Steady two, so we want to do same. Disable variable 2, but we leave the optimization for this section. So we can go ahead and compute duplicate our cell voltage. We call this the full cycle prediction. That'll be the full cycle prediction. Data set should be the full load cycle prediction. We want to do some manual changes to the x-axis. 610. I want to change here to, and we would like to plot, see how it changes. We want to change the legends to lower left. As you can see here. Go to global 1. And we want to name this as predicted. Any changes. So you're able to see our predicted ones We go on to add global valuation. Which we'll name this as standard deviation steady one. We will have to put in an expression for this, which will be small lb dot cut e so xp. Go on to add the operation should be standard deviation we want new table. It has evaluated it for us. We're going to duplicate this. Name this as 32. That will be parameter estimation, which we'll use. And we will also evaluate that data set. Go on to duplicate same, which we'll name 3. We want data set to be follow cycle 3, which will evaluate in here. So we want to do a time selection. Want to make a range 0 to 1 6 7 1. Let's evaluate that gives us our results. We've been able to do an evaluation of this work to see within time range of this what this evaluation will be. So this brings us to the end of this work section. And thanks for following till this end. If you have any question, kindly drop your question in the comment section.